Now we're going to review a couple things with linear and exponential functions, and then we're going to start looking at their graphs and comparing their graphs. So in this problem it says the two tables below represent a linear function and an exponential function. Which type is each function? And then we're going to explain. So this is kind of what we did before. We're just reviewing how to look at a table and tell if it's linear or exponential. So when you're looking at it, the first thing that you check no matter what is you check the x values, and you make sure that they're increasing or decreasing by the same interval. So like if we look at our x values, what are we doing to go from one x value to the next? Well, 0 to 1, 1 to 2, 2 to 3, 3 to 4. You're adding 1 each time, and so we're good there. So the x values are increasing by the same amount. But then to be linear, remember, you have to either add or subtract that constant number. And then your exponential functions, and I'm looking at the y values with this, you're going to be multiplying to go from one number to the next, okay? Or if you're multiplying by a fraction, that would be kind of essentially dividing to go from one to the next. But we always think about it in terms of multiplying. So that's what we're going to check for. So we're going to look at our y values, and we're going to figure out what is the pattern. And if it's adding or subtracting to go from one to the next, it's linear. If you're multiplying to go from one to the next, it would be exponential. If it's neither of those, it's going to be some other type of function. Or it may not be a function at all, okay? And so we're going to just find the pattern. So what are we doing to go from 5 to 10, 10 to 20, 20 to 40, and 40 to 80? What is there a pattern there? And if you kind of think through it, well, like, okay, if you're thinking, okay, I could add 5 to go from 5 to 10, but if I add 5 again, that's not going to give me 20, so I know I'm not adding a constant number, or it doesn't have a constant rate there. So then I'm multiplying. So what can I multiply 5 by to get 10? Well, if I multiply by 2, it'll give me 10. Okay, so does that work? 10 times 2, does that give me 20? Yep. 20 times 2, yep. 40 times 2, yep. So my pattern here is I'm multiplying by 2. So that means that this would be exponential. So this would be an exponential function. And the reason for that is because you are multiplying by that constant factor here to go from one y value to the next. Okay? So, well, what kind of function would this be? Well, check your x values. So are my x values going up or down by that same amount? Do they have the same interval between each one of them? And yes, you're adding 1 to go from one x value to the next. So we're good there. So now let's look at the pattern between our y values. What am I doing to go from 8 to 11, 11 to 14? And you can kind of sit here and you can think, okay, am I adding a constant number? Am I multiplying by a constant number? And eventually you'll figure out, okay, well, if I add 3 to 8, I would get 11. 11 plus 3 gives me 14. If I add 3 again, I get 17. And then if I add 3 again, I get 20. So the pattern here is I'm adding 3. And so, because I'm adding a constant number, that means that this one would be linear. Okay, so that's kind of a review. So now, something that we have talked about with both of these types of functions is how to write the equation from a table. So I'm going to review that. And so we're going to first start with this table right here, and we're going to write an equation that would represent that. Well, it's exponential. So the exponential function looks like this. And so if you kind of go back and review your notes, you'll remember that A is your y-intercept, and then B is whatever that number is that you're multiplying by. So when we write our equation here, we have to figure out our y-intercept. If you think about what we talked about, the y-intercept is where it crosses the y-axis. So you could like graph this and see where it crosses. Or if you remembered, the y-intercept is the coordinate that has a value for the y and it has a 0 for the x. You would realize that this right here, that coordinate is your y-intercept. So that means that this graph is going to cross the y-axis at 5. So that's actually where it starts. So it would be 5. And then, remember, b is what you're multiplying by, and we figured out that we're multiplying by 2. And since the x's go up by 1, that would be our b. And so that is the equation for that table, for that exponential function, okay? So now how do we write an equation for this table right here, which was a linear function? Well, you could put it in a couple different forms, but usually the easiest one to put it in, if it's linear, is slope-intercept form. So remember, this is your slope. That's like your rise over run, or you could use the formula. That's your y-intercept, and so we just have to find those things and plug in. So remember, your slope is like where you take your y values and subtract them, and then you put it over your x values subtracted. That's actually what you've done here to find these numbers. So your slope would actually be your y values over your x values subtracted. And so you just take that number over that number. And so your slope would be 3, and then it goes in front of x. So that's the first part of your equation, and then you just have to find your y-intercept. So y-intercept has a value for y and a 0 for the x in the table, so that would be your y-intercept. So there you go. So there are your two equations, okay? So now we're going to start looking at their graphs. So I'm going to review, we're going to sketch a graph and kind of review and look at what is kind of weird about these. And then after that, I'm going to actually show you some ways to read the graph that will be good to know, okay? So what we're going to do is we're going to sketch a graph of both of these on the same exact graph, okay? So we're going to start by sketching our exponential function. So remember, this is where it crosses the y-axis. So I'm going to go up to 5 on the y-axis and put a dot. And then remember, that tells me if it grows or decays. Since that number is bigger than 1, it's going to grow. So it's going to, we're just sketching it for right now. So remember, growth starts kind of level and then it increases all of a sudden. Okay, and now this one, remember, graphing lines, you start with the y-intercept, which is 8. So that was 5. So 6, 7, 8. That would be where that one crosses the y-axis. And then the slope is 3. So that means we go up 3 and then right 1 to graph our line. So there's that point. And then so to go the other way, I go down 3 and left 1. So 2, 3, left 1. 1, 2, 3, left 1. And then here's my line. So I can draw my line through those points. And there we go. Okay, so, and actually I'm going to extend this just a bit further so we can kind of compare them. So something that I want you to realize whenever you're comparing these kinds of graphs is exponential functions have something kind of special with them. And so you just need to realize what is so special about an exponential function, okay? So the thing I want you to kind of look at here is when you look at your line, which is your linear function right here, it kind of steadily increases. It's increasing kind of like what's in the table. It's increasing by the same amount each time. So linear functions, I need you to realize in the graph, will grow kind of steadily. Okay, and that's the reason for that is because it's just increasing by that same number each time. But with exponential functions, that isn't what happens, because remember, exponential functions are going to kind of start out low, but then as they kind of go along, if it's a growth, it's going to kind of take a turn and then it's going to increase very quickly or dramatically, okay? And so exponential functions will grow dramatically. Once they start growing, they increase very, very quickly over time. And so the one thing that I need you to make sure that you remember is exponential functions will always, eventually, okay, sometimes it takes a little while because it does start out slow, but it will always eventually exceed, in other words, go past other graphs of linear functions, and then when we get to quadratic functions, you'll realize it also passes quadratic functions eventually, okay? And so one thing that you might see is they might ask you questions related to that concept, okay? So we're going to look at some of these and just kind of make sure that you know how to answer those types of questions. It says, in this problem, which function grows faster in the long run? Well, if you remember this concept and they give you two equations, you know if it's got an exponential function in there, that one's going to be the one that grows faster, just for the simple fact that once it takes that turn, it's going to go up very, very quickly, okay? And so just by looking at the equations, you can tell which one that's going to happen with. So like figure out which one is the exponential one. And remember, exponential functions have x as the exponent. So which one has the x as the exponent? Notice this one is linear because it's actually in the mx plus b form, slope-intercept form. This one has the x with the exponent. And so you would automatically know, you wouldn't even have to graph those because this is a growth, that one will eventually pass that one. And so remember, they name these functions with the letter that they use. So you would say that the g of x function would be the one that would grow faster, okay? Now, something else that they might ask you is something like this. It says, for which x value does one exceed the other? So in other words, since this is the one that's going to grow faster, what x value, so you're looking for the x value, does this one pass the other one? And so that's where you're going to actually graph it. And so you can sketch a graph, but that would be a little harder to kind of tell. So what I would recommend is to graph these on Desmos. So you'd pull up the Desmos app and you would graph each one on the Desmos. So I'm going to type in my first one, and instead of f of x, remember f of x is the same thing as y, so I'm just going to type in a y. So for my first one, I'm going to type in y equals the 4x plus 1, so equals 4x plus 1. Okay, and so notice it does graph it for me, and you can zoom out so you can see it better. And then I'm going to graph the other one. So instead of g of x, I'm going to just put a y. It makes it easier on me. So y equals 3, and then you press the A to the B button to the x power. And then notice they'll graph them. So what you're looking for, so let me see if I can zoom in here, is, do you see, so the exponential function is in purple, and then the linear function is in green. So at first, notice the exponential function is kind of flat, but then when it takes the turn, the linear function kind of passes it. But if you notice up here, so let me zoom into that spot right there, up here, that exponential function, so remember the exponential function's in purple, goes past the linear function again. That's when it starts growing dramatically. So you're looking for what is the x value that's just past that point, because that would be when the exponential passes the other one. So all you have to do is click on that point, and it'll tell you that point. And then, well, just past that point would be when the exponential passes the linear. And so it says, so notice that coordinate is at 2, 9. So 2, 9. And it's saying, for which x value does one exceed the other? So it would be just past 2. So you could say, and it depends on kind of what answer they're looking for, but you could say just past the 2. On the x-axis is when it'll exceed the other. Or if they're asking, like if you notice down here, this one says, for what positive integer of x does one pass the other? It would be whatever the integer is right after 2, which would be at 3. So if they're looking for what positive integer will it go past the other one, you would say at 3. Okay, so it just kind of depends how they're wanting you to answer it. Okay, and they'll tell you. All right, so let's answer this one. It says, for what positive integer of x will the value of this function first exceed, which means go past, the values of this function? Okay, so just like what you did before, you're going to graph each one of these equations. So I'm going to go down here, and I'm going to just change, since this was my linear function, I'm going to keep it as my linear function. So that one would be the 2x minus 1 Okay, and then this one, I'm going to just go over here and change that 3 to a 2, because that's the only thing that changed here. Okay, and then we've graphed it. So now notice my graph is kind of zoomed out from before, so I'm going to zoom back in. Okay, and then, and actually, you know what, I think that this is supposed to be, let me see, I think one of these is supposed to be different, so let me see, because I might have accidentally typed it wrong. Yes, okay, I think that this right here is supposed to be a plus sign, so let's change that to a plus. And then, so I changed it in my graph. And then we're going to look at it, okay? So you're looking at where the exponential goes past the other one. So right here is when, if you look, the linear function has actually kind of gone above the exponential. So that is opposite of what you want. What you're wanting to know is when does the exponential go past the linear one, because that's the one that exceeds it. So right here is the point you're looking for. So we're looking for the positive integer. Remember, integers are your positive and negative whole numbers, and it also includes zeros. So we're looking for the positive integer that where this one just goes past the other one. So the x value is 2.66. So what is the first positive integer right past that? Okay, and so that would be 3. So it first exceeds this function at 3. So there you go.